right, so our lesson for 112 is what we're going to go through right here. Okay, so 112 is all about multiplying together polynomials. Okay, so applying the distributive property in order to first double distribute and then secondly distribute polynomials where we could have three terms in each of them. We could have two terms in one, three terms in the other. So that's what we're doing today. So we are going to be in our textbook. So if you want to open up to page 43, that's where we are going to start off. Okay. A quick note before we get into our lesson, because this is going to come up a lot, we have to recognize the difference in how we would approach these two problems, thinking about our order of operations from earlier in the year. So a quick reminder that if a question said simplify the following and it was 5x to the third plus 7x to the third, we handle that very differently than multiplication. So 5x to the third plus 7x to the third, remember we would add the numbers in front, 5 and 7 to make 12, and then the exponent, the power, is going to stay the same, 12x to the third. Versus if we multiplied, we would multiply the numbers in front, 35, and then x to the third times x to the third, we would add those exponents. Sorry about that. Come on. X to the sixth. Okay. So our first problem that we're going to do is going to be called double distributing. Okay, that's what we'll start with in our textbook. We're on page 43. Okay, so these are both examples of polynomials. Okay, 2x minus 1 is a polynomial, x plus 8 is a polynomial. They're actually called binomials because they each have two terms, right? 2x and negative 1, and then also x and 18. Each of them contain two terms. Okay, so the way that we distribute across these multiple sets of parentheses is we double distribute. So we're going to multiply this 2x to the x and to the 18. So we'll do that first. We're going to do 2x times x. It's 2x squared. Then we're going to do 2x times 18 plus 36x. Then we also have to distribute this negative 1 to both. So we're going to do negative 1 times x minus x, and then negative 1 times 18 minus 18. Notice now both sets of parentheses are gone, okay, and we have a long polynomial with four terms in there, okay? So now our job is just to combine any like terms in order to fully simplify. So we look for any like terms. We see we do have a couple like terms with the plus 36x and the minus x. So if we're going to fully simplify this, we'd say 2x squared plus 35x minus 18. That would be our fully simplified expression. Okay, so first objective for today, can we double distribute? And this is something you should have seen last year in math class, maybe probably just like a half-day lesson. Okay, but let's practice this a little bit. Okay, so we'll do this one more together like this. Okay, so if we did a, I'd multiply the x to both, x squared plus 3x. Then we'd multiply the 5 to both, plus 5x plus 15. And then we combine any like terms. We have these two like terms in the middle. X squared plus 8x plus 15. Okay. Why don't we attempt D as well? Because that one's a little bit trickier. Okay, so let's first distribute the negative 2a to both. So negative 2a times a squared, that'd be negative 2a to the third. Then negative 2a times negative 1, that'd be plus 2a. Then we multiply the 5 to both. Plus 5 times a squared, that's 5a squared. And then 5 times negative 1 minus 5. If we look at what we're left with, there's actually no like terms. The only step we would complete this with is putting it in standard form where our exponents are all in order. We'd say negative 2a to the third plus 5a squared plus 2a minus 5. Now our exponents are in descending order, 3, 2, 1 here, and then no A. Okay. All right, why don't you guys do B and C on your own in your books where you have all that blank space. Okay, so complete B and C. All right, let's see how we did. So B, simplified, we should have got 3y squared plus y minus 4. And then C should have gotten 4m squared plus 10m minus 6. Okay. So if you didn't get that, you can pause this and check your work for those steps in between. All right, so let's try example 2. Okay, so now we are on, I lost my page number. I believe it is page, it's either 44 or 45. I apologize. Lost my page number there. So we are double distributing here again. Okay, we have two binomials. Okay, so we're going to multiply the x to the third through. Okay, so x to the third times negative x squared. That'd be negative x to the fifth. Then x to the third times 11. That'd be plus 11x to the third. Then we're going to multiply the 9x to both. 9x times negative x squared. That'd be minus 9x cubed. Then 9x times 11 plus 99x. Okay, now we look for like terms. So we do have some like terms. Okay, the positive 11x to the third and then negative 9x to the third. So fully simplified, we'd say our answer is negative x to the fifth plus 2x to the third plus 99x. That's standard form. Our exponents are in descending order. Okay. That was still a 2 by 2, okay, where we had a binomial and a binomial. Next goal is going to be, what do we do if we have a trinomial? Okay, so notice this is considered a trinomial here because we have 3 terms. This is a binomial. So we have a couple questions off to the side here, so we can do this on page 48 or 49 since it's separate from our book notes. So you really could approach this multiple ways, and that's where I threw in there, is there only one way to find this product? So your gut intuition is probably correct here. So how many times are we distributing? Really, we're distributing 3 times, right? You would multiply this x to the third to both. You'd multiply this 2x squared to both. And you'd multiply this negative 3 to both. Well, if we're doing it that way, sometimes that can look a little messy because you have all these loops. So one thing to remember is with multiplication, you can always rearrange the order. So my suggestion would be, if you have a trinomial, let's actually move that, a trinomial and a binomial. Let's move the binomial to the front because then we're only going to be distributing twice. Okay, so that'd be saying 2x plus 5 times x to the third plus 2x squared minus 3. Notice what happens now. Now we're going to be multiplying this 2x to all 3 of these, and then the 5 to all 3 of these. So it's only going to have to distribute through twice. It's going to feel a little bit more organized. Let's do it. So 2x times x to the third, that would be 2x to the fourth. 2x times 2x squared would be plus 4x to the third. 2x times negative 3 minus 6x. Then we multiply the 5 to each term. So 5 times x to the third be plus 5x to the third. Then 5 times 2x squared plus 10x squared. And 5 times negative 3 minus 15. Notice now we have really 6 terms currently. So now it's just a combining like terms problem here. So 2x to the fourth doesn't have anything that it pairs up with. Then we keep looking. We have a 4x to the third, 5x to the third. So we combine those, plus 9x to the third. Now we keep looking. So we have a 10x squared. but that doesn't have any partners, right? Any like terms. So we can write plus nx squared. We have a negative 6x, but there's no like terms with that either. Minus 6x. And we have that minus 15 still. That has no like terms. Okay. Notice when we combine the like terms, we look for the highest degree exponent first, right? So we look for 4s first, then 3s, then 2s, then x's, then just numbers. Because that saved us a step of having to rewrite at the end. Okay, so that would be our simplified expression. Let's keep practicing this. Okay, so now we're on example 3. And I apologize, I lost my paper. I believe it's either 48 or 49. Okay, so same process here. So now we're going to multiply this 3x to all three terms. Okay, and then we'll multiply the 4 to all three terms. So all just staying organized and taking your time as you're doing this. So 3x times x squared, that'd be 3x to the third. 3x times 6x plus 18x. 3x times 10 plus, oops, my mistake there. Caught it before we went any further. 3x times 6x, that would be 18x squared. Okay, then 3x times 10, 30x. Now we keep going. We multiply the 4 to all these, plus 4x squared. 4 times 6x plus 24x. 4 times 10 plus 40. We look for like terms. So start with our biggest exponent of 3. There's nothing there. 3x third. Let's see. So we have a plus 18x squared and a plus 4x squared. So that would make plus 22x squared. Then if we keep looking, we have a 30x, color, 30x and a 24x. Those together make plus 54x. And then we do still have the plus 40 at the end. Okay, so that would be our fully simplified answer. Okay. Let's leave this one for another day. So last thing I want to do, so again, we still have some space on 48 and 49, hopefully. It says write the area of the rectangle as a simplified expression. Okay, so what this goes back to is area. Remember that's area equals base times height, where we multiply our two side lengths together. So if we looked at our problem here, well, we're given our two side lengths. So really this problem becomes just taking x squared plus 7 and multiplying that by x to the third plus 3x minus 1. Well, let's do that. Why don't you guys get some feedback and try to do this on your own right now, and then you can check your work as I work through it. All right, so let's see how we did. So we're going to multiply the x squared to all three. So x squared times x to the third, x to the fifth, x squared times 3x plus 3x third, x squared times negative 1 minus x squared. Then we multiply the 7 to all three. So 7 times x to the third plus 7x to the third. 7 times 3x plus 21x. 7 times negative 1 minus 7. Combine any like terms. So x to the fifth, that's going to still be by itself. Then we have, if we look, we have a 3x to the third. We have a 7x to the third plus 10x to the third. Then we still have just a minus x squared. We still have just a plus 21x. And we still have a minus 7. Okay. So here's our expression. Let's check and see if they gave us any units. It didn't. Let's say that these were measured in inches. Okay. So if these were measured in inches, then area, since we're in 2 dimensions, we would say this expression measured in inches squared. Okay. You will see some on your homework tonight where it says write out an expression for the area of a rectangle with these side lengths with expressions that are polynomials given to you. So this would be multiply together our two side lengths and simplify. Okay, so that's it for today. So our objectives, can we multiply together polynomials? So we started with first goal of multiplying two binomials together. Okay, that was just double distributing. And then we went into some with a binomial and a trinomial. So that's what we have for today.